Hey everybody, it's Andy here with Scott. Today we're going to be making a Christmas special project, which are some wooden train tracks and some wooden trains. We're going to do some designing work on Onshape so we can make the designs from scratch, and then we'll cut them out on the machine, and we'll show you the process on how to do that, and I'll kind of explain how it works on Onshape. And if you want to modify the designs or make your own, we'll have all the designs available and you guys can make any train set you want. So yeah, I guess we'll get started. It's been a long time since I've done a screen record and teach people on what I'm doing, so I'll try my best, and I guess we'll go from there. So yeah, getting into Onshape. So this is Onshape here. I guess just as a preface, the reason, so Onshape is a CAD program. Basically, we use it for designing stuff. At our company, we use it to design everything that we make. And the reason why we use Onshape, one, is a very powerful software. You can basically design and model any like mechanical system. So as you can see here, we have like examples of different LongMills. You can do simulations, and you can assemble things, and you can transfer different parts between different designs, and it makes it really easy in that way. The other reason we use it is because there's a free option. So if you're using it for personal use or educational use, you can get a free license, which basically gives you unlimited access to Onshape. The only stipulation is that anything that you make is open to the public, which means that if you make a project on Onshape, people can like search it up and then copy it as well. So if you're like us and we want to keep some of the designs private, we obviously pay for this, but we also have a bunch of CNC projects here, so that people, as long as you have the links to it, or you can search this up in the search bar, you can find the designs and you can copy and make this yourself. And so for today, we're going to make the design in our CNC projects folder, and these will be open for the public, and you can make a copy of the design on your own personal Onshape account and modify it. And the other good thing about Onshape is that anytime we make a change, it's kind of like a Google Doc where it updates everywhere. If we design something and we put it out in the world and someone suggests a tweak that we want to make, then we can tweak it in the design, and it'll be like when you go back to update things, you can like it'll be to the latest version, and you can go back to all the old versions as well. So yeah, Onshape is a really great program. We've been using it for many years, and so that's kind of the background of it. So just to get started, we'll go to the create button here, create a document, and we'll call this wooden train project.
Yep.
Train. Press create. So when you do that, you create something called a project, or sorry, a document, which is basically like everything that contains the project. You'll see on here, it automatically creates a part studio. So part studios are basically the beginning of each part, or like it's the file that contains the part essentially. So we can design individual parts in here. And the other thing that I do a lot is to make multiple parts in a part studio, which we'll show kind of later down the line. So yeah, so you can, I'm not going to go into the navigation part of it, but I'm going to start at the top sketch. So another background piece of information about what Onshape is. So Onshape specifically is called called parametric CAD, which roughly means that you can use dimensions and primitive shapes to create the designs. So in this case, basically create sketches, and then you can extrude them into shapes, and you'll see that in a second. So the first thing I'm going to do is select a plane to start a sketch. So I'm going to choose this top, press sketch, and this basically means I can start drawing on this plane. First thing I'm going to do is just draw a circle. And you can see here, I just go onto the circle, draw the circle, and then it turns, you can see it's blue because it's not a defined shape. if I press D or I go press this button to dimension it, right now it says it's 36 millimeters. I can change this to any dimension I want. So in this case, maybe I'll do 6 millimeters. And now this circle is 6 millimeters in diameter. The next thing I'll do, so right now I'm going to design the train track. So, and I'm just going to make a rough sketch without providing specific dimensions. I'm just going to get the general shape of it. So in this case, I have the train track here. And then I'm going to basically just make 2 lines here. I'm going to use the mirror function to just mirror this line across this symmetrical plane. You can see now basically I have this kind of like shape that's reminiscent of this kind of like profile. The next thing I'll do is just make kind of like the mirror version of this on this side. Use the line again. Use this line as a mirror and then just mirror that. So now, right now we have kind of a general like shape of what this train track looks like. And so I'm just going to use the trim tool to cut away the excess lines here.
It'll still allow you to change the dimensions of all that after you've cut that away?
Pardon?
It'll still allow you to change the radius or the dimension of the circle?
Yeah.
Cool.
So right now you can see most of the dimensions are undefined. They're all shown in blue. This means that we can dimension them after the fact. So that's the beauty of parametric CAD, which is why it's used so much in the industry, is because you can select each individual line, change the dimension of it to adjust the tolerances of the part that you want. In this case, I'm just going to do it this way just to demonstrate like the basic fundamental of how this parametric CAD works. So in this right now, we have a closed shape you can see here, which roughly is the shape of the train track. And you can see also in Onshape, it shows that it is a closed shape by chaining this middle part gray. And the next thing I'm going to do is just extrude it. So you can see now we've turned a 2D sketch into a 3D shape. I can specify the depth of it. And now I make it, just going to use an arbitrary number from now. It's just 6 millimeters. So I'm extruding it from this plane up, and then now it's 6 millimeters. So now you can see we have a very general train track shape. The next thing we need to do is make the parts where the wheels are going to go. So I'm going to do that by selecting the top of the sketch, or top of the part, pressing sketch, and then this time I'm going to create 2 rectangles to represent the train track. Right. I guess this button doesn't work. Okay, I'm just gonna do this.
My middle mouse button doesn't work?
I don't think so. Yeah, so now I just mirrored this train track. And as you can see, oh, it does work. Yeah, right now, as you can see, I haven't defined these as well, but we're gonna go back and define them. And this time, right now, so last time we extruded it up. This time we're just gonna remove it. So we're basically taking away from the original part. And maybe we'll do, what, 3 millimeters for this? And you can see now, we kind of have something that looks like a train track.
Ooh.
Yeah, so if you think about it this way, if you just like duplicate this process where you create a primitive part, you start removing and adding things to it, you can kind of make anything that you want. This is not good for sculpting, but when you're making like mechanical parts that need to connect with each other, parametric CAD is a really powerful tool. So I think that's a good kind of early demonstration. I'm just gonna delete everything and then start over, and then I'm gonna like get into now that I've shown kind of the advanced part, I'm gonna start to do this in a higher level. So I'm gonna go back and do the top sketch again. There's a couple of good practices in CAD. One is to utilize the symmetry of the parts themselves. So I have to talk about defining the sketch. So what defining the sketch means is that it doesn't, every dimension of the part can be defined, like it can't be changed. Usually you start with one origin point or the datum, and then everything references around that. So right now you can see that the rectangle is blue because they're completely undefined. So I'm going to start to define this sketch with some dimensions. So in this case, I need to choose a width. And I'm going to start to use some variables as well, which means that you can change the number here and use it throughout the project. And that will set a specified number. If you looked at some of Scott's other projects, you'll probably see variables created to change like the width of the step stool or change the size of the diameter of where the cup is going to be. So I'm just basically using the same process. So to do that, I'm going to type in the pound sign, which lets me create a new variable. I'm going to call this variable width. I'm going to make the value, well, I'm going to see how wide this is. Maybe I just use a straight one to check. You got those calipers?
Oh, calipers? I put them away. You made fun of them.
I didn't make fun of them. I made fun of myself.
It's true.
But of not being able to use them as
Where'd they go?
effectively. Oh, it's right here.
See, you do like them.
Okay, so I'm just gonna like measure this width. Looks like it's about 4 inches. Is that 4 inches? No, 60 millimeters. Am I reading this right?
1.6 centimeters.
This side is inches. Right, okay, 1.6 inches. Okay, that's probably close enough. What is that in millimeters?
Well, top side will give you centimeters.
40 millimeters. Okay, let's do millimeters. Okay. All right, so the width is 40 millimeters, so I'm just going to do 40 millimeters.
This is what happens when you're using 40-year-old calipers.
Yeah. All right, so now you can see that these two lines are defined because you can't change the size of the rectangle anymore. But if you... Okay. Now we're defined on the length, so we want to make a length as well. So I'm going to go back and do length. Spell length wrong.
Happens.
And that's going to be, well, can kind of just be arbitrary. Maybe we'll do like 120 millimeters. I'm going to do 120 millimeters. All right, so now, oh, I spelled length wrong. I'm a dum-dum.
It's not even Monday.
Now you have that on record. And he's a dum-dum. All right, okay, so now we have a fully defined rectangle. One side is, oh shit. Okay, one side is the width. One side, oh, didn't save. Okay, one side is the width, enter. One side is the length. And now we have a rectangle with one side being 120, one side being 40. And when we want to change this, or when you guys want to change this to make different sized tracks, you just have to type in the number that you want to make it a certain length of, and now it'll just make it 150 millimeters instead. I'm going to use 120 because that's like that number goes into a lot of other numbers, so I suspect that's like a good place to start. But we can go back and change it or whatever. All right, so that's kind of like the basis of the track. Now we're gonna add the what do you call these? What should we call these? Nubs.
Nubs?
Yeah, well, let's add the nubs. So for nub, I'm gonna draw a circle. Now I want to see how big I want to make it. That is 11 millimeters.
There we go.
All right.
I'm just testing you.
I'm gonna make a variable for the nub size as well. And this will be the male side. Actually, I'll just call it male nub. Male nub.
Thank you for editing.
Male nub is 11 millimeters. All right. And now we also need to see how far we want to put it from the main part of the track. Let's see how far this one is. That is about 77.5 millimeters. I'm suspecting that this is supposed to be like a 12 millimeter, and then you kind of just adjust the hole size. I'm just gonna make a reference construction thing and then use round numbers. No, that's not right. That's like 18. I'm gonna make another variable, nub length. And that's 18. Okay, beauty. All right, so there's the nub length. I have the female side, I'm probably gonna use 12 millimeters. It seems like based on my measurements, they're using like rounded metric numbers, and usually I try to use rounded metric numbers myself because that's just easy. And then the width of the whatever this outside part is called, that's 24 millimeters roughly. 24 millimeters. Wait, that's not 24 millimeters. I'm getting inches and
I'm going to buy you a pair of digitals right now.
Yeah, that's 6 millimeters. All right, ladies and gentlemen. Shit. Sorry, Louis. You're gonna have to do a lot of cutting for this.
He's used to that with me.
The metric is 60.
I say I'm a bad Canadian when I use imperial.
All right. Okay, so now I have this nub. I'm gonna make the female nub. Nub. Female. And that's 12 millimeters. Or you can do like male nub plus 1 millimeter, and then you have a 1 millimeter space. Should we do that? Should we get really fancy?
It's up to you how fancy you want to get.
Okay. It's 1 plus
Combination.
male nub. Makes it.
It's smart enough to know that too, eh?
Well, no. Apparently
Oh,
not.
yeah.
I think I have to specify the unit. Oh, there we go. Yeah. Amazing. So,
It's pretty sweet that it auto defines though.
yeah, I've been using this software for a long time, so I'm like an expert. Okay, and then I'm gonna add my width. Oh, I should mirror this. And then from there to there will be
So, 1 plus.
be the length, no, nub length. That's gonna be 1 plus nub length.
Now, is that going to put 1 on each side, or is it going to divide 1 by both sides?
Pardon me?
Are you doing the variable for like here to here?
I don't understand the question.
You did a variable for this to offset by 1.
Yep.
Are you doing the same variable on this guy? So is it going to add 1 to each side, or is it going to divide 1 by 2 sides?
It'll be like 0.5 millimeter on each side.
Okay, so it's
technically.
going to divide 1 by 2.
But we
Okay.
can go back and change it.
Yeah.
Yeah.
I was just curious how it would interpret it.
Yeah. And then I'm going to do nub width female, which is nub width plus 1 millimeter. All right, so that's 7, and then I'm going to trim the excess. You don't, oh, I actually don't really need to do this, but so I'm not gonna, because it kind of makes things a little harder. Anyways, okay, so I have this kind of shaped up, so I will extrude it. And you can select the faces that you want to extrude. In this case, I just want to do that. And then I'm going to do the thickness of this. Be about 12 millimeters. Yeah, it's about half an inch, right?
Just shy.
I'll just use half an inch as a Actually, I'll just make another variable for this. Track thickness. That's half an inch. Okay.
See? Inches and millimeters.
Yeah, it's hard to be a Canadian. Okay, so now we have our straight piece. Now I'm going to make the tracks. Okay.
How do you want to measure that?
Should we do from outside or from the inside? Actually, we need to see let's do the track width first. That is 11. That's about 12 millimeters.
Oh, they're just square too, so that makes it a little easier.
Track. Channel. 12 millimeters.
Good thing to know considering we're going to have to make wheels that go down these, so.
That seems a little big. Oh, that's 6. See, isn't it nice to be able to change the variables here? 6.
There you go.
All right, so that's 6, and then get roughly. I'll do from outside to outside. Where's my straight track? That's about 30 millimeters. No, 30. Okay, 30. Let's do 30.
Sure about that?
I don't know. 30. Cool. Okay, so now the track depth looks like about 4 millimeters. So track depth. $4 Cool. Okay. Ta-da! So here we have our first defined track. Cool. Okay. So there's going to be a couple things that we're going to have to do with this, but I just want to show you another thing. So the other cool thing about CAD is that you can make things in the universe like this of the virtual. You can make it in the virtual world. So, well, I'm going to insert the track. Ta-da! There's another one. And then I can use something called mates to line them up with each other. Oops, I messed up. I want to mate it to here. There you go. Yeah. So you can see here, there's a conflict where it's kind of bumping into this. So I kind of messed up here. Another cool thing you can do is edit in context. So you can edit within the assembly. And in this case, I need to make this slightly shorter because I think I made it longer than it needs to be. Oh, let's see, nub length, right? Nub length female. Nub length female. This should be minus 1 millimeter, I think. See if that does the trick. Somehow I feel like I still fucked something up. All right, let's reinsert this. And then do the side. Solve. Ah, yes, perfect. Okay, so now we can see when you put this together, there's a millimeter gap around everything. So that's good. If we want to be even more tight on the tolerances, I could probably make this 0.5 millimeter. So I'll just go in and do that quickly again. Nub length female. And Scott was saying, you were saying that they make the tolerances pretty loose to make them compatible with like other train tracks, right?
From what I read, because there are more than one manufacturer of wooden train tracks, they, yeah.
Yeah.
They're a little loosey-goosey so that they can all fit together so everybody can have all of the wonderfulness of wooden train track building.
Yeah. Okay, so from here, I'm just going to point out a couple things that we need to do for the design that pertains to CNCing specifically. So the first thing is that, well, I'll just use this again, where it connects here. So CNC machines, their weakness is that sharp corners, the maximum radius that you can do is based on the radius of the bit. So in this case, when it cuts this corner, there's going to be a radius here where it's going to collide with this corner. So I want to go and add a fillet to take that up. And you can add these features with the fillet tool. Ta-da! I'm just going to do, what should we do?
What are we cutting it with?
Our radius, if we do an 1/8 inch, then we need about a 1.6. Yeah, 1.6 will do the trick. So the radius of an 1/8 inch bit is rough. It's whatever half of 3.175 is. So 3.2 is 3.2 is bigger than 1.
You speak in millimeters?
Yeah.
So we're talking about an 1/8 inch imperial bit, but we're talking.
Yeah, because an 1/8 inch bit is 3.175. Double 1.6 times 2 is 3.2, which means that a 1.6 millimeter is bigger than the radius of an 1/8 inch bit, which is going to be big enough for the tool. So the rule of thumb here is your radius just needs to be bigger than the tool that you're using. And so in this case, that's fine. And I'm just going to radius these corners too and do these guys as well.
That's right. Furnace turned on. You're Brazilian, man. You don't want to freeze.
The other things, if you want to do to make it look cool, is you can radius these too. This is like personal preference. I think I'm going to not leave them radius, but you can see I can click on the lines, choose the radius diameter, or sorry, the dimension, and then just like go from there. If you want to make another variable. Now everything should fit together, and I have the radiuses here, so it looks smooth, looks good. And the other benefit of using fillets is that if these are kind of be the weakest points, I think, like they're going to be the easiest to break. So having a radius kind of helps smooth out the stresses, forces that go apply on it. So should be a stronger part too. So yeah, there's a very simple straight track.
Yay.
Alrighty, so I'm gonna just rename this tracks. Alright, so I guess from here, we're not just gonna be making straight tracks. So why don't we try doing a curved track? So I'm gonna do another sketch on here, and I'm gonna use some of these lines as the reference for the curved track. There's this tool, I guess it's called the use tool, where you can click on features on the original draw, like the surface, to use for your sketch. So in this case, what I'm gonna do is just like make a curve that goes like this way, if that makes sense. And then, and I don't need all this stuff here, so I'm gonna just delete it. Okay, so let me think what's the best way to do this. I think I'll just do a circle. I'm just gonna do a simple 90-degree curve in this case. And then I think it'll just go around this way, if that makes sense. There you go. So now I'm gonna make a track that goes around like this. I'm gonna use this, oh, actually, need to, okay, so another cool thing about CAD is you can do references. So if you don't do dimensions, you can say like this line has to be next to this line and things like that. So these are all the tools here. The coincident one is basically like this thing needs to always be touching this thing. Okay. So you can see here, now that I've made this coincident, the width of this circle to this circle matches this to this. So yeah, that's basically the shiz.
Somebody was thinking, eh?
When you've done this for years, you learn to like think about the best, easiest process. The next thing I'm gonna do is make a center line. So it's just gonna be how do I say? It's just for a reference essentially, which is gonna be in line with the center of this track, so that when I draw the circle on this side, it will be a little easier. So there's something that we have to decide on, kind of, because this one is like two-sided, right? Like they have the channel on each side, which means that if you want to like go the other way, you just have to flip it over. But if we want to do a turn, we could either do a flip and then like cut the groove on the other side and do it the same way, or we can make it so that there's like a dog bone, and then you make these separately and then you put them in. So you just have to flip them the way you want. Or we make like multiples of ones that are like different directions.
Well, I will say, from what I read online, people complained about one-sided tracks.
Right.
They got grumpy with them because you can only use them in 2 orientations, not 4. So
Do you want to make two-sided? Like we can make two-sided.
We can do it.
Yeah.
we have the power.
Cool. Okay. I guess we're making two-sided tracks. Okay, I just need a straight line here. Circle. Dimension this as male nub. Do the things that stick out. Mirror it across this construction line. Choose the width of this guy, which I think it's called nub width. Nub width. And then this should be nub length. Nub length. Yes. Okay. Cool.
Something else to point out that you haven't talked about yet, that unless I'm mistaken, from my foray into learning Fusion, is construction lines are basically just reference points. So they don't actually show up within your design. They're just there as a reference more than anything. So
Yes. Yeah. You make a good point. Yeah. So for the audience, these construction lines are basically just reference lines. So you can like draw them to like make centers, or if you're doing mirroring like I'm doing, if you have symmetric parts, then you can use them to mirror and stuff. Yeah, but when you actually use them, they won't show up. So yeah, okay, so we have this new train track, and we have the nubbins. So I'm just gonna extrude this. And another thing, right now the way that I'm doing it, it'll combine the 2 parts together into like one part, but we don't want to do that. We want to just make a new one. So you can, in the extrude tool, you can change it to new, which will make it into a completely separate new part. So you can see it's created this new part. And the thickness, I'm gonna choose thickness, track thickness.
which is probably a good time to bring up naming, Andy, and naming your parts.
Oh, yeah. Let me just, well, we're gonna finish this part.
All right, I'm just making sure you're actually going to name them.
Okay, so you can see on the left side, all the parts are there. So you can turn on and off if you want to see them. I'm going to turn off this one so I can just work on this guy. And from here, I'm going to do the grooves. I'm just going to use make another construction line. Let's see if I can get the center of this book guy. Yes. Okay, that's the center. And then I have to make the grooves.
Beware of the grooves. Oh, does Louis know that reference? Does Andy know that reference? Emperor's New Groove.
Yeah, no. Okay, so that's the track channel width. Oops.
Man, you're furry. I know.
And then the width of the channels. Oops. That should be...
What's up? Oh, you like the belly rubs?
No,
okay.
that's not it.
So does Andy.
Track outside, okay. How do I make this even?
Mm-hmm. That's what I'm wondering.
I'll show you a trick. I'm going to make a construction line between these two, and then I'm going to make a reference point between these two, And then I'm going to make it coincident to do this. And now it's centered to everything. Yeah.
Because everyone followed along with what you just said there. Yeah.
I don't know how to explain this. I'm just too good at this now. And then I'm just going to trim.
This may not be like a formal step-by-step tutorial. This might be, this is how we kind of, well, we as in Andy, how he designs stuff, so we can hand off to you guys to build cool stuff. So if you can't follow along, don't feel bad, because I know about 50% of what he's talking about right now.
Yeah, this is like master level. Anyways, well, you know, it's cool to see the process, I think.
Absolutely.
And once you like play around with this stuff, you'll see how it works. So I think it'll be okay.
Yeah, because I just started messing with Fusion this week, and I'm already understanding most of what you're doing. I may not be able to do it myself, but I understand everything that you're doing.
Track channel. Oh no, I messed up. I just need to select the right face. Sketches. There you go. Ta-da! Look at that.
Cool.
Oh no, this size is too big. This should be track depth. There you go. Okay. Okay, so yeah, we made a 90 degree, and we're gonna make this into a, how do I say, a flippable item. Two-sided. And so I'm gonna use this other thing that can basically like replicate this on the other side. So, wait, actually, what's the best way to do this?
I'll hop down. Here, go find your bed, buddy.
Okay, so some more complicated stuff that, you know, I'm going to make a new plane, which basically is like another surface. And then this surface is going to be halfway, like in the center of this part. So that center of the part would be, the distance from that side to the middle would be the track thickness divided by 2. And now you have a plane, which I can mirror the feature. So I choose the thing that I cut, which I believe is this one. Oops. Okay, part mirror, feature mirror. Oh, feature mirror, the extrusion, the mirror plane is the center. And now,
Sweet.
now I've put it on both sides.
That was some master level stuff right
Oh,
there.
yeah.
I'll give you that.
So now we have this 90 degree. Go into the assembly. Now we can add our part 2. I'm just gonna call it a 90 degree. We can call it something else later. Okay. Mate this. Oops. Oh shit. Mate this. Solve. Ta-da.
Virtual train track.
There you go. What do you think about that? Now you can just start stitching it together and make it as big as you want.
That's why we have a whole bunch of oak sitting there.
Cool. Let me just think. Let me just make like a wait, yeah, like a mock-up. So with an assembly, if you don't fix one of the parts, the whole thing can be floating. So I just usually stick one of these as a fixed part. Oops. Copy, paste. Rotate 90, 180. Oh yeah, that's right. It'd be cool if we can do this in VR, wouldn't it? Okay, I give up on doing it this way. Yeah, so my pet peeve with Onshape is that it's kind of like tricky to manipulate things in the 3D space. Oh shit, I messed up. Okay, I need to get this part on. You know what? There's other ways to do this.
You could just rotate it minus. So yeah, you could do that too.
Okay, that looks cool, I guess.
They fit together and the radiuses are working, so that works.
So what do you think the math needs to be to get these all to fit together?
I think that's why they have long tracks and short tracks and why they have 45s and 90s.
Probably. Well, let's try making them. And then I can export as whatever size we want. Does that make sense? Because I just need to change the variables.
Yep, at the end of the day, that's
Cool.
cool.
Should we rip some board?
Time to fire up a table saw.
Yep.
Okey-dokey.
So I think what we'll do is we'll rip it to 1/2 inch, and then we'll cut out these shapes, and then I'll make another version that's shorter, and then we'll just like make a bunch of them.
Cool.
Yeah. And I think this might actually be a good project to use Kiri Moto on, because I can export as ST. So we have two options. One is to use Vectric, export these as DXFs, and then you have to specify how deep they are, which is a little tedious. Or if you do Kiri Moto, it can do it all in one go. Same as the guitar project. So
Which is up and coming.
yeah, let's give it a go.
Give her a whirl.
Yeah. Okay. Thanks for checking in.
Next.
We'll be starting this going. Yeah.
Get it rolling.
Yeah.
Probably hasn't warmed up.
Oh,
Are you square into my table? He's a cowboy, man. He's a cowboy.
so much.
Let's see how these fit together. Back to the drawing board. Back in action. While we were away, I also made a 45-degree track because the wood that we have is probably not wide enough to do a full 90, or at least we'll end up wasting a lot of material. So I basically just split a 90-degree into two 45 degrees, which you can find here. Yeah, so all right, so let's talk about how to do the programming. First and foremost, just to cover how to export things from Onshape, we were just talking about either exporting them as DXFs or doing them as an STL. The reason I went and chose to do it as an STL is because you can do, like, it can carry over the depth values rather than if you do a DXF, it's just 2D and then you have to specify which pockets you're going to do in 3D, or I guess like as a depth.
Exactly.
And I thought it was a good opportunity to show off Kiri Moto, which is a free online. Let's get into it. So yeah, I'll just show you how to export. You just right click on the part that you want, press export. And in this case, we're going to export as an STL. So choose your name here, STL. You can choose text or binary format. Binary format is good. For units, choose millimeter. For resolution, you can do fine. And then just download it and just press export. I believe I already have, yeah, I already have it downloaded here, so I'll just skip that. Next thing, if you want to go into Kiri Moto, you just need to type in this address in your browser. And I have this job set up already, but I'm going to make a duplicate of this and then start it from scratch. So we'll just delete the old part. All right, so first of all, Kiri Moto kind of is done so that you start from the left. You have a couple of tabs. You can kind of start from the left and then get extra options on the right side. Kiri Moto is unique in that it's specifically designed for use with STL files or 3D files. So that's why we downloaded from Onshape or STL. So just go to start. I have this set up already, but you probably need to set this up yourself for the first time. So if you go to setup, choose machine, choose CNC as your device type. On these settings, we're going to use a LongMill, so we'll choose LongMill. If you want to modify these, you can also do any generic Gerbil, and then I believe you can customize. Yeah, you can customize these settings, or you can take this CNC one. Yeah, so you can go into CNC your machine and then customize it, so you can change this volume and stuff. That'll just change the size of the working area size here. So that's good. And then the next thing you can choose is tools. So in our case, there's already a setup for 1/8" end mill, but you can also add more tools, and you can name them and add different features of them. So there's end, ball, and taper. But I think for this case, we'll stick with the 1/8", which is the default already. The next thing is we're going to import our file. So in this case, we have our 45°, and you can see if you have stock enabled, it'll center it to the stock. In our case, in our case, we actually do want to use stock, and I'll explain why. For the 45° angle, we actually need to do a flip operation because we have the track on both sides. So the way that I've set this up is, first of all, I get the material. Yeah, so we have the material here, and so what the stock setting does is let you input the size of the shape or the stock, and then it'll center the part in the stock, and then when you do a flip, it'll use that as a reference. So essentially what we're going to do, in this case, like I made the stock width the width of the material, so you can take a pair of calipers and measure it. In my case, it was 87.5 millimeters. The depth, I made the size of this part, because essentially what we're going to do is just size it within here, which is roughly about 1 millimeter. There's a bit of a gap in between. And then the height is the thickness of the material. So use your calipers again, measure the thickness of the material. And in our case, we're using 1/2 inch material, so it'll be 12.7 millimeters. So when you look at the binding box here, you can see that it basically floats the part inside. And I believe if you make this, let's say 20 millimeters, it'll show that the stock is higher. And then if you are using a thicker part or thicker material, you can carve away until you get to the part, so that you can use stock that's not the same thickness. But in our case, we just cut down the material to 1/2 inch because all the parts are going to be 1/2 inch, and we don't have to go and mill out the top of it, and that just makes it a little easier. If your stock is thicker than your part, are you able to center it or choose top or bottom, or is it just going to do it automatically? I don't know. I never tried. Let's see what happens. Oh yeah, so it doesn't center itself.
Okay.
But I think if you play around with it, it should you should have like there's like options that I'm not familiar with, and I think you can like center it and you can adjust where it is in the block.
Cool.
You can find documentation on this on their website as well, so I'd suggest checking it out as well. For their stock, I set the width, and basically what we're gonna do is we're gonna flip it in the y-axis. So we're basically gonna take it like this and then flip it over like this, rather and not like this, because we're cutting on this long piece of material. I'm just gonna delete all these pre-established operations, but and another thing I've done is on preferences, I've set show origin, and if you show origin, there's a little dot here where it shows where the origin point is. You can choose if the origin point is in the center of the block or on the bottom left. In our case, we're going to use bottom left because we're going to use the reference point of the left edge as our way to do the flip. So yeah. Okay, so we have our part in here, we have our stock set up, and then we double check that our origin point is on the top left corner. And now we're going to start adding some milling operations. So if you go to the bottom here, you can start stitching together the milling operations. The first thing we're going to do is do a roughing pass. So click roughing pass, and then if you hover over it, these are all the settings. So first of all, we'll pick the tool, which is going to be our 1/8 inch bit. Our step down is 2 millimeters works well because our the pocket here is 4 millimeters. So you'll just do 2 passes there. Step over 0.4 is good. Feed rate 1600 is good. Plunge rate 250 is good. And then leave stock is basically how much extra stock you want to leave. For that case, we're going to just leave it as 0 because we want the actual thing to be cut out. You can also do, these are clear voids, I believe is like, let's see, well, we can just try it. Sometimes I don't remember exactly what the thing does, but at least when you check the simulation, you can see what happens. It looks like it doesn't really matter. Yeah, so in this case, we just want to cut the top part of it out. I believe if you want to go back to the regular, to start changing these things, you have to go to view, arrange, or like change the mode. But anyways, yeah, so the first operation is going to be a roughing pass because we're going to cut out this part, and then we're going to flip it over and then cut the other side of it out with the outside cover as outside profile as well. So my next next operation is going to be a flip operation. So press flip, and now you can choose what axis you want to flip it on, either X or Y. In this case, we're going to do Y. If you want to switch between the front and the back, you just press flip and you can change modes. So in this case, we did the roughing on the top, we flip it, and now we're going to do a roughing on the other side, and then we're going to do the outside pass. So now we have the flip, we're going to do a roughing with the same settings as before, and then we'll just do we'll just slice it just to preview it, so that's the same. And then we're going to do a, so what an outline pass does is it basically just goes on the outside of the profile, and it cuts the outside of the STL file. So in this case, yeah, so I have outside only, these are my settings, step down is 1.5, feed rate is 1500, plunge rate is 250. For this, I don't use tabs, I just let it cut all the way through. It means that you can save time on like actually sanding off the tabs, but usually you want to make it a little slower in terms of the step down in the feed rate. So, you know, these settings worked for the oak, so yeah, you're probably going to be okay, but just keep letting people know. If you want to put glue underneath just to keep it in place at the last pass, you can do that too. So let's see, let's slice it. So now you can see we have the outside pass, and then we have the roughing pass that cuts the middle track, and then the outside pass that goes all the way around. And yeah, that's basically it. So what we're gonna do is I'm gonna start with the other side. So that one, this is the first side. We're doing this side first without cutting it on the outside because we want to keep it in the material, and we only want to take the part out once we get to the second side. Otherwise, it's gonna fly all over the place, right? So yeah, so do start, slice, and then export. You can change the name here, and then you download it. And I've already created the file here for first side. And then you can arrange, flip it to the other side, slice. Now we're doing the second side. Export this. I already have that side also. And you should have both your G-code files in wherever you downloaded it to. And yeah, we'll get into actually cutting the parts out. we're getting started on the cutting process. All right, so we have gSender open. We have it connected to the machine. The first thing we're going to do is open the first side, which is just the roughing pass. And here I'll go over how to set up the material. This is where I show the cutting process. So we got our material here. What we're going to do is we're going to find a reference point. We had those like right angle things that we made in the past.
Oh,
These guys.
it's like you're talking about a triangle?
If you want, you can like set one of these up, and then you can have a place to like set it up like this.
Yep.
However, this is Scott's machine. He's already has these grooves put into the board, so I just like butted it up against this, and then I line up the edge of the. I just line up the edge of the whole stock against the edge of this other edge.
He assumed that everything was nice and square.
I mean, it was square.
It wasn't too bad.
Yeah, it worked pretty well. Oh yeah, so I mean, basically you need to make this square, because when you flip it over, if it's not square, the ones they won't line up. But because you surface this, I know that this side is going to be square, right? Yeah, just making an assumption. Anyways, all right, so we got our material. We just square it up so that when we flip it, we're gonna flip it like this, and then now this edge is gonna go against this edge, and it's important that we know the width of this, because when we flip it over, you can kind of imagine what's a good way to demonstrate this. So like if it's like this, and you don't know where the axis is, you might flip it over. It might be slightly off to the right or the left. So when I measured this, I'm probably within 0.2 millimeters. So I know like I have a chance of shifting left to right by 2.2 millimeters, which is I think pretty good for what we're trying to do. But yeah, so I'm just gonna clamp this to the edge here using the bottom as a reference point. And then we have these nice toe clamps to keep our stuff in place.
Can you just show again how you align it here? Just so we have this.
Yeah, so aligning it, I just use this edge here, like this MDF edge here, and then I use this like little lip that Scott cut out back in the day. Yeah, so just check that it doesn't move, and then we're good. So I'll bring the machine all the way to the corner here. Okay, so what I want to do is I want to position this end mill to the bottom left corner. So we're going to use our touch plate for that. And it's also important that you get this corner pretty accurate, because if you're not lined up, when you flip it, it won't be lined up either. Thankfully, the touch plate is very handy. So start up the touch plate, jog it to the starting position. That's too far. Okay. Now I'm going to do the probing cycle. Press probe, touch. I'm going to hold it in place while it does this probing. Okay, there you go. So we got our 0 now. Before I get started, I just want to remind everyone that when you flip, you need to keep the position. So you won't have to 0 anything until you move to the next position or like do the next part. But in this case, like don't switch things until you finish the job. Alrighty, so I'm gonna turn on the router to start this job. Alrighty, so we have our first side done. I'm just gonna unclamp this and then do the flip. So flip, put it back in, use that reference point. Clamp down the part. Cool. Okay, that's pretty secure. So next I'm going to load the other side file, second side. And just to remind everyone again, you don't have to change the position. You don't need to re-zero anything. You just start it from this position here because we've already zeroed at the beginning. So I'm going to start this bit again and then start the job.
That one works.
Nice. I guess you just need 0.5 millimeter. Alrighty, we're done. Just scoot it out of the way. We'll see how close we got on the flip. Big reveal. Ta-da! Okay, so we got both sides cut pretty evenly.
Yep.
And these should be the same width, so that's looking pretty good too. Yeah, so you basically just need to rinse and repeat this process until you get enough tracks to do your
Design.
whatever design you want. So, I mean, we've already started putting together a bunch.
It's like a little mini indie circuit. So we just need 3 more curves and 2 more straights.
Although I feel like we should just make a whole ton of them and then make a big track or something.
Realistically, that's what we should do.
Yeah, this is like the editing magic where
Yeah.
you cut out a whole bunch.
One piece turns into 100.
Yeah, and then we have this giant train track set.
Ridiculous.
Yeah. I'll just show how to do the straights because that's kind of the other part. And the straights are pretty easy. All right, let's get back to Kiri Moto. Let's oops, not this. Let's arrange, delete our old one, and then import the straight file. So just right click, export, STL, blah, 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 blah. I already have that version here, so I won't download it again. Now you're going to double click and then drag it to the bottom left corner. And
Does it actually like stop at 0, 0? Like it won't let you drag it past?
nope, yeah,
Oh, cool.
which is nice because
Yeah.
yeah. So there's that. And if you want to do more than one, I believe you can just like duplicate. You can add another one. Yeah, you just drag both to wherever you want it to set it up. Look at that. See, you can line up 2 at the same time.
Fancy.
Maybe we'll just go with that actually. Anyways, yeah, so we're gonna do the same roughing pass and everything. So step downs 2, 1600 feed rate, 250 plunge, just use these settings, and that'll do the little channels, and then I will add the outline. So same settings as before, outside only, blah, 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 blah. Slice. And now we have 2 setups that'll do the cutout. I'm gonna export this. Oop, not import. I'm gonna export this. Download. Tracks. 2 piece. 120mm. Save. And then I'll open up gSender, load my file. And there she is. You can double check that it looks okay. Yeah, that looks pretty good. And you have the origin point is in the same place. So I moved the machine back to the origin point, but I'm just gonna shift it up to the next spot that I'm gonna start cutting on. Okay, so I'm just gonna jog it up roughly there, so it lines up with where the last spot I cut. And then the only thing that's changing is on the 0. So right now our Y position is 101.5, but I'm actually gonna 0 just this. So now our 0 point is, our origin point is right here now. Now when I start the job, it should cut out and start everything from there. And you can double check if that's set up correctly by looking at the visualizer and making sure that the bit visualization is in the right position. So let's give her a go. Yeah. Nice. Okay, that was pretty close.
You're a madman.
Okay, cool. All right, well, that covers our how-tos for the tracks and the cam. Let's make some trains.
Choo-choo.
Let's make a train. We're just gonna kind of model it off of this guy, or like the other guy.
Where'd the caboose go? The engine.
Nice. But we're just gonna make it CNC-able. All right, so let's get into Onshape. We're gonna use the front side as our starting plane. And we're gonna sketch out a train shape. So what does a train look like? So basically the idea here is gonna be that I'm just making like a 2D profile of the train. You can kind of like have free reign over this because we're basically just doing, well, I think in woodworking standards, making something like this is fairly straight. Like you have a lot of creative freedom on this. So I just made a 3/4 inch block, and then we're gonna put with some wheels on it, and then we should be able to make the train. And then we're gonna put magnets on the front and the back to do the do. So I'm just gonna export this and then bring it into Kiri Moto.
Boss.
Oh, it's working. Nice.
Oh, all over my table.
And then I guess we'll just cut it out of this guy. Start the router. Run the job. Perfect timing.
You do or he does?
I do.
I can do that so you don't hurt yourself.
Sure. That's all right. Yeah.
Hang around here. You're going back there.
That's why I wanted to build CNC machines, because my hand-eye coordination is not that good, and my handiwork is not that good either. So I just what is? Oh, it's stuck.
Shit.
You need an aluminum mallet, I guess.
Or I may need a tiny drill bit so I can drill it all the way through, and it'll just
I guess wrap up this project. Yeah, so thanks for coming to check out us building these train sets. I hope that people make good use of the files and get to try out building this for themselves. And yeah, if you like the project, make sure to say hello and share your projects with us. And we'll keep doing lots of cool stuff. So if you have any ideas, just let us know. Cool. You want to say anything?
Keep on chugging.
Keep on chugging.
So there you have it, folks. One toy train set done and ready to chug out of the station. It was great having Andy in the shop. I hope you guys learned something with this video, because I know I did, and it's one of those things that we're always learning. So part of the reason we did this project was its simplicity, but we also saw a lot of value in the project and being able to customize it for lots of different uses. Uses? That's the word I'm looking for. You know, you can use it for good old school, just playing with a train set. You can customize it with seasonal things like Christmas trees and pumpkins and stuff. And you can also throw somebody's name on there as a, you know, a gift for a baby shower and stuff like that. So it was a simple project, but it was also one that we saw a lot of mileage out of. So if you liked it, if you didn't, comment below. Let us know what you liked or you didn't like. As always, please make sure you are subscribed. Ding, Louie, you got the bell? Not a boy. And we'll see you around the CNC.